Educational Module, Machine Learning, Learning Unit, Core. Regression. Regression analysis is a statistical, predictive modeling technique for estimating the relationships between a dependent variable often called the outcome variable and one or more independent variables often called predictors, covariates, or features. Suppose that you've been given a housing price dataset of New York City. This dataset contains information such as size, locality, number of bedrooms in the house, etc. Your task here is to predict the price of the house by studying the dataset given to you. Solution. Model a relationship between the dependent variable and independent variable. The data about the house, such as the number of bedrooms, the size of the house and so on, are known as the independent or predictor variables. These predictor variables are used to predict the response variable. The response variable in our case is the price of the house. Response variables are also known as dependent variables because their values depend on the values of the independent variable. So, given the relevant data about the house, our task at hand is to predict the price of a new house. Such problems are solved using a statistical method called regression analysis. Regression analysis is primarily used for two conceptually distinct purposes. First, regression analysis is widely used for prediction and forecasting, where its use has substantial overlap with the field of machine learning. Second, in some situations regression analysis can be used to infer causal relationships between the independent and dependent variables. Regression analysis is widely used in the business domain for sales or market forecasting, risk analysis, operation efficiency, finding new trends and etc. Regression is one of the most common tasks in the machine learning field. Regression and the other popular tasks will be presented in the following pages. Regression. Given the pattern X, estimate a real value variable Y. For example, performed an estimation of a company's revenue next month. Binary classification. Estimate the value of a data point or pattern, two possible values. Multi-class classification. Estimate the value of a data point or pattern, range of different values. Clustering. Group a set of data points in such a way that objects in the same group cluster are more similar to each other than those in other groups. Novelty or anomaly detection. Determine unusual observation given a set of past measurements. What is commonly considered unusual is an event that occurs rarely. Both classification and regression algorithms are part of supervised learning. In both types the prediction of an instance's class is performed. Classification algorithms are used when the output class's values are restricted to a limited set of values, while regression algorithms are used when they are continuous real values. Regressors are also called function estimators and aim to capture the general trend on the data since the data points are going to be very noisy in most tasks. There are many regression analysis techniques, but the three most widely used regression models are linear regression, logistic regression, polynomial regression. The most common form of regression analysis is linear regression, in which a researcher finds the line or a more complex linear function that most closely fits the data according to a specific mathematical criterion. The linear regression algorithm is one of the most widely used and one of the fundamental supervised machine learning algorithms due to its relative simplicity and well-known properties. In a linear regression model, the relationship between the dependent and independent variable is always linear. Thus, when you try to plot their relationship, you'll observe more of a straight line than a curved one. The goal is to find the line or a more complex linear function that most closely fits the data according to a specific mathematical criterion. For example, the method of ordinary least squares computes a unique line or hyperplane that minimizes the sum of square distances between the true data and that line. Logistic regression is a machine learning algorithm used to solve classification problems. It is called logistic regression, because its fundamental technique is quite similar to linear regression. Logistic regression is a predictive analysis technique used to predict a dependent variable, given a set of independent variables, such that the dependent variable is categorical. For example, yes or no.